Welcome to The Explainer. Today, we're diving into something incredibly cool. We're breaking down a live demonstration by Bennett Fenner from the team at Zed. We're going to unpack exactly how he built an Agent Client Protocol, or ACP compatible, coding agent, right there in front of a live audience. If you've been trying to wrap your head around how modern AI editors actually talk to different AI models under the hood, well, you are in exactly the right place. Okay, let's just look at the landscape right now. You probably recognize a ton of these names. I mean, over the last year, we've seen an absolute explosion of AI coding agents, right? We've got terminal user interfaces, major model providers building out their cloud tools, Codex, Gemini CLI, Cursor, OpenCode, the list goes on and on. But if you're a developer, you've definitely felt the friction here. The ecosystem is super fragmented. We have all these incredible tools, sure, but they're all stuck in their own little silos. So here is our roadmap for today. We'll start with the AI agent fragmentation problem. Then we'll enter the agent client protocol. After that, we'll look at the implementation blueprint, and finally, proxy tools and bootstrapping. Part 1, the AI agent fragmentation problem. So how exactly can we bring our favorite agents into one unified interface? Well, this is the exact challenge the Zed team wanted to tackle. It really comes down to standard agents versus ACP agents. On the one hand, standard model APIs are inherently stateless. Think about what that means. To get them to act like an agent, you literally have to attach the entire conversation history, send it over to the endpoint, say the Anthropic API, wait for a single message back, and then repeat that whole clunky loop all over again. It's just not efficient. But an ACP agent? That unlocks fully interactive, stateful sessions. You get real-time streaming updates, and crucially, proxy capabilities that let the agent talk directly to your local environment. Which brings us to Section 2, Enter Agent Client Protocol. To solve this massive stateless fragmentation problem, the Zed team helped pioneer a seriously powerful solution. It's called the Agent Client Protocol, or ACP. Essentially, it's a JSON RPC-based open-source protocol that allows agents and clients to communicate through one unified interface. Think of it like the universal adapter plug for the entire AI coding world. If you're familiar with LSP, the language server protocol that standardized how our code editors talk to language compilers, well, ACP is doing the exact same thing, just for AI agents. And honestly, the ecosystem adoption is catching on so fast. Up to 40 clients already implement this protocol. We're talking about heavy hitters here: Zed, OpenClaw, JetBrains, Obsidian. And on the agent side, tools like OpenCode and Cursor have ACP modes built right in. OpenClaw is even functioning as both a client and an agent. So this isn't just some neat proof of concept. It is rapidly becoming the actual industry standard. All right, Section 3, the implementation blueprint. Let's get into the weeds a bit on how to actually build this. So during the demo, Bennett actually joked that he's a Rust developer with basically zero clue about TypeScript, but he still managed to build this connection live in just a few minutes. Here's the blueprint for initializing that connection. It takes 4 clear steps. First, the agent responds with the protocol version it supports. Second, it generates a random session ID. Third, it instantiates the coding agent. And finally, it returns that ID back to the client. The absolute key takeaway here is that the session ID acts as your anchor. Every single time you start a new thread in your editor, it creates a session to represent that specific conversational thread. Okay, so once we're connected, we actually need to see the AI thinking, right? Standard agents constantly run into this annoying issue where the AI is processing away, but 0 tokens are actually showing up in the UI. ACP completely solves this for streaming outputs. First, the agent receives a prompt paired with that unique session ID. Second, it triggers the model's stream on text event. And third, it emits a session update with the agent message chunks. Bennett showed this by connecting the Anthropic SDK stream directly to Zed's debug view. And just like that, the invisible tokens were streaming right into the editor UI, chunk by chunk. It's so cool to see in action. And that leads us to our final part, Section 4, Proxy Tools and Bootstrapping. This is where things get wild. This is the moment the AI stops being just a simple chatbot and starts acting as a true proxy, interacting directly with your actual development environment. Let's walk through handling proxy tool calls. Say you ask the agent to add a comment to a TypeScript file. First, the agent emits an initial tool call update over the protocol, with the status set to In Progress. That's what gives you that nice little loading indicator in your editor. Second, it executes the local file read or edit. And third, it emits a tool call update containing the status and the diff content. And what's totally brilliant here is that the editor, Zed in this case, automatically handles the biffing of the old text and the new text, displaying it perfectly for you. This proxy file system feature is exactly why this protocol is an absolute game changer. Because it proxies the file system, the agent can actually read unsaved changes directly from the editor's active buffers over ACP. Think about that. If you've just typed out a massive block of code but you haven't hit save yet, a standard API wouldn't see it on your hard drive at all. But over ACP, the agent sees exactly what you see on your screen in real time. Now, for the network-curious folks out there, Bennett did clarify a really interesting technical detail during the Q&A. Right now, this connection runs entirely locally over standard I/O, but remote transport is actively in development, so very soon you're going to be able to host the agent remotely while still keeping that completely seamless local editor experience. Okay, now for the absolute climax of this live demo. Because the agent can now read and write files via ACP, Bennett essentially bootstrapped the agent, using the agent to upgrade itself. He literally prompted the agent to add a terminal tool to its own codebase. So the agent reads its own source code, writes the new terminal tool capability, compiles it, and then, using its brand new tool, it successfully runs a sleep 5 and an ls command right there in the editor terminal. I mean, it is literal AI inception. It upgraded its own capabilities in real time. And the craziest part? All of this was built in just 15 minutes. As Bennett Fenner casually summarized at the end of the demonstration, that's how you kind of build an ACP-compatible coding agent in 15 minutes or so. Just think about that time frame, taking a basic script, wrapping it in a standardized protocol, giving it the ability to read unsaved buffers, stream live tokens, and then write its own tools. It really speaks volumes about the incredible developer experience this protocol provides. So I want to leave you with this provocative thought to wrap up our explainer today. We are looking at a future where the walls between these tools are totally coming down. If the barriers between all AI agents and editors were completely removed, what tools would you connect to build your ultimate workflow? The blueprint is finally out there. Now it's time to build.